Good morning. Everybody hear me okay? Welcome to Remars. Thanks for coming. My name's Chris Kruger. I'm the CTO at Miso Robotics. Here to tell you a little bit about how we made a robotic fry cook named Flippy. First, I'd like to start with asking kind of the old question. Where is the future we were promised? Right? Blade Runner was supposed to happen in 2019. The Future and Back to the Future, 2015. And Robbie the robot from iRobot was supposed to have happened in 1998. Yet here we are, no flying cars, no robot assistants. So I'm a little disappointed. But I think I can help a little bit on the robot side. I'm not sure about the flying cars. In robotics and what we do, there's been an explosion in the last few years in food tech. There's a number of new companies that are coming on board that have, well, things from coffee kiosks to pizza delivery systems to mobile ramen restaurants. There's a number of companies that are reimagining kitchens and the way that food gets made. We're part of that. We're proud to be a part of it. And this is actually one of the most advanced kitchens in the world. It might not look like much, but this is a White Castle in Maryville, where the first Flippy 2 was installed last fall. And since then, we've cooked over 50,000 baskets of food for them. And as part of that, that's part of really the culmination of a 5-year journey for Miso. It took us that amount of time to create and harden a tech stack that allowed us to iterate through multiple different applications for that. The initial versions of this product actually flipped burgers. It was a kiosk, it was a cart that could be put in front of the stations, and eventually it morphed and grew into the product that you see here, an overhead rail with the arm on it so that it's out of the way, it's efficient, and it interfaces well with the humans. And now that we've got Flippy out into the field and it's proven itself, brands are starting to adopt it. We're able to expand the number of restaurants that we deployed into, as well as the number of brands that we're deploying with. And now we're starting to create follow-on products like Flippy Lite, the chip-making robot that we're making for Chipotle. And we're also into CookRight, our automated computer vision and IoT product line that monitors and tracks usage of back-of-the-house activities in kitchens, including coffee service for Panera brands. But here, I don't think anything does justice as much as a quick video that shows you Flippy in action. Looks easy, right? Well, once it looks easy, then you're in the right spot. And the brands have lined up to partner with us on this and our other products. We're excited to have such great partners to work with. And they kind of self-select as far as those that are interested in being on that cutting edge, those that really want to adopt what's coming next. But how did I get involved? Well, I'm a dad, I'm a husband, I'm a maker. I believe in open, I believe in a growth mindset and flow. I've had over 60 global products, number of patents. I'm a big supporter of the Linux Foundation, of Android, Arduino, and ROS. These are foundational technologies that millions of our products today are built on and really make a big difference. But none of the things that I do can be done without great collaborators and great teams. I've been fortunate to work for a number of great companies as well as with some amazing people. And in the process, make some really cool products, like the original Droid from Motorola, the first mainstream Android product, and a car-eating dinosaur, because why not? And finally, robots that run around your house and clean up after you. You know, I do this because those products help make our lives a little bit better all the time. And for me, personally, there's been a lot of wins. One of which was in December 2009, when I was able to give my entire family a droid for Christmas. And getting to see, you know, my mother, my father, my wife, my son, sitting around playing with this new device and being immersed in that new technology was really a moment. You know, you get to see those very few times, but you get to see how our technology and the things that we do can make big difference in small degrees in people's lives over time. And I see back to that moment, and I look forward to robotics today, and I think robotics is really just at the starting gates. This is and feels very much like what is going on, what went on with mobile phones around that time, right between iPhone and Android, where you're kind of on the cusp. We're on the precipice of a large number of applications really hitting. And I think that's largely because we've got a number of key foundational technologies that are just maturing now. Between computer vision, robotic motion, simulation, as these different technologies mature to a point that makes them easy to integrate for commercialization, we also have the rise of ROS and the potential for an ecosystem that can create a robust industry for a large number of applications. I think it also sets the seeds for a number of companies to be the next Apples and Googles. But all of these technologies and many more are used just to make Flippy. And these are only the ones with cool icons. There's dozens more that every robotic software engineer has to be familiar with and has to be an expert in several of them just to make a single application work. This can be a daunting task for any software engineer. And when you add them all up, well, you've got lines of code in products that have exploded over the last 20 years, code that has to be reused across multiple products and multiple applications, and it makes it harder and harder to test. In mobile phones, we were able to take hundreds of phones and put them on automated test racks and run them from tens of thousands of hours to harden those stacks, to get them to the point where you can use them all day, every day, to get them to the point where they're something that you can hardly go to the bathroom without. But with robotics, it's going to be a lot harder to do that. We're going to need a bigger boat. Or we're going to need a different way to solve the problem. Or we're going to stay in the trough of disillusionment for a long time while that long tail of problems, of small one-off problems, is worked through. So how do we do it? At Miso, we built a sustainable foundation of layered testing, starting with tens of thousands of unit tests, adding on component and integration tests, and finally, a number of different system validations. Now we have a lab full of, well, I guess it's probably one of the biggest kitchens in Pasadena. Lots of different Flippies and robots in there cooking every day. That's not easy to do. And in my previous life, we had built a warehouse of houses so we could clean houses 24/7 with lots of different robots. Each layer in this pyramid gets much more expensive. And once you get out there with your customers, make sure that you find some good, durable alpha testers, folks that really want the technology and are in it for the long haul. And finally, once your fleet expands and your applications go mainstream, make sure that you're monitoring the activities that happen out in the field with precision. For us and for robotics, I think the real change that can happen is in simulation. 10 years ago, it wasn't really practical to develop in a simulated environment. Today, at Miso, every Flippy, which is unique, gets built in sim first. We retrofit restaurants with our Flippy at the fry cook because we don't want them to change their restaurant. But what that means is every Flippy has to fit into that restaurant. And by building out the sim, we can make sure that it's going to do exactly what it's supposed to before it gets installed. And then we can test all of the performance enhancements and feature updates that we give the life of the product. And we expect Flippy to be able to be in those restaurants for many years. And for your average software engineer, the way they're going to see it is part of their integration flow. As they submit their code, a number of cloud-based robotic simulations is kicked off, testing that change across an entire fleet of products and allowing them to see not only will it pass the test, but also what that performance looks like so that they can monitor the trends over time with a change. Of course, hardware in the loop testing is also a vital part of that, but the real game changer for robotics business, in my opinion, is the simulation. And cloud-based simulation allows us to run that in parallel. That way you can get that feedback in minutes instead of days or weeks. Previously at iRobot, it would take months before full system validations were done. This allowed developers to get really good feedback within hours. And as we move from the continuous integration to the continuous deployment, we start that flywheel of data. Putting the products out into the field, collecting the data from them, analyzing it, and making the products better. Allowing us to expand to new brands and to expand to new products. But there's a few things to keep in mind as we collect that data. First, you've got to mind the gap. Look for the things that are out there that you didn't anticipate. What are the things that you need to build back into your testing, and especially into your simulation, to make sure that you're capturing the real-world difficulties that your products are facing? For us in robot vacuum cleaners, it was carpet drift. Every carpet fiber has a tendency to cause the robot to not move straight, but to veer to one direction or the other. We were able to model that and build it back into the sim and get a much more realistic test set. For Flippy, it was the wobble in the baskets when it was full of food, making it a little more difficult if it rolled or pitched to one side or the other. As we build that into our simulation, it helps our sim environment as well as our product be more robust and more lifelike. The next thing that you should do is look for the signal in the noise. What is the frequency that we need to be looking at the issues in the data so that we can find those key performance indicators that really make the difference between success and failure in our products? It's not always easy to find, but they're there. And once you've worked through the big hitters, the big issues, and you've got your performance to where you need it to be, go look for the anomalies. Look for that smaller group of issues that are really causing pain for your customers. Or maybe it's a smaller subset of a large fleet that's seeing really bad performance. When you find those anomalies, cluster them, find what they have in common, and figure out how we can solve those problems. Because you really want, especially in robotic applications, everyone to be happy with the performance. Oop. And once you've got the automated testing, the simulation, and the monitoring all put together, like we do at Miso, you're able to really dive into the development process and increase the velocity of your developers, giving them the proper tools to really know how their designs are going to work in the field and where they got it right and where they need to do it better. And for us, that culminated into Chippy. Now that we've got a robust development environment where a number of tools have come together for us, we were able to, when Chipotle came and asked us to make a chip-making robot for them, we were able to simulate the entire device prior to even responding to them, giving them a good idea of what type of performance and what it would be able to do. We were able to use the baseline technology that we had to enhance it, adding things like salt and lime flavoring into the cooking process to give them a more complete product. They loved it. And this product will go to market in less than a year because we have the right tools in place to develop that product. So this is really how Miso has made Flippy and established our technology. And if you believe in us and our quest to change kitchens and to really bring them into the future, well, consider investing in us. We're a crowdfunded company. Thank you. And I know we've got time for Q&A, so if anyone has questions, feel free.
I have a question.
Go ahead.
So I was super excited to see you on the agenda. I think we read about this, the Wall Street Journal about a year ago. Was the first that some of us heard about this. Was it, can you talk to us about the economics a little bit more, the ROI? Was it in response to the chronic labor shortages that really catalyzed the demand for this? Or was the underlying economic proposition so strong that regardless of the labor shortages, companies were willing to embrace this?
Absolutely. Great question. Is it the labor shortage, and just for the folks that are on the camera, is it the labor shortage that has accelerated the interest in this or the ROI? And it's really both. So we sell Flippy as a service, and the service cost for the product replaces the labor, or the labor savings basically pays for the unit itself.
What time frame?
Immediately.
Wow.
Yeah. So, well, there's a small setup fee for it, but yeah, within a few months. But I think it's the labor shortage that's really driven restaurants to engage with us about trying to solve that problem. So I think it accelerates that adoption. because with Flippy, you've got an employee that shows up every day and does what it's supposed to all day long. So we've seen quality of service go up at restaurants, as well as some of the restaurants we've installed in being able to stay open longer and more regularly because they don't have the problems of filling it. The fry station is really one of the stations in a restaurant that's the less desirable positions, and it's hard to fill and keep people in. And that's really a big part of robotics, is finding those applications that really humans don't want to do. They find them dull or dirty or dangerous. Yeah. Thanks for the question. Yeah?
So, can you talk a little bit more about the hardware challenges you face in the end you deliver hardware?
Absolutely.
So that, and second, the restaurant business is not a tech business, and you're deploying technology into a place where the previous staff are probably not used to such level of technology. So how is that going in terms of that staff being able to manage this technology and operate it, and the skilling of that?
Absolutely. So 2 questions. One, what are some of the hardware challenges that we've faced with Flippy? And the second one is how has the staff responded to the products? So the hardware, this is a sophisticated piece of equipment. We have 8 different cameras and really a very strong edge compute device on location. The units run autonomously. They don't need to be connected to run. We really mostly keep them connected so that we can monitor performance and support them actively. We do have a 24/7 support team that's on call because many of our restaurants are 24/7. So we're basically on the ready at any time. We've had a number of learnings from the hardware side, especially as we're learning what that longevity of certain parts are, whether it's a gripper or a camera that could get misaligned or some grease on it from usage. Really kind of working through those. We're also, while we have the promise of open source and we use ROS for a lot of our system, we also find that not all parts are equally supported in the ecosystem, and many of them require a fair amount of integration to switch out. Some partners are quite good and they support open source, which makes our integration efforts easier. And we're still kind of learning as we go here what the longevity of certain pieces of the technology are going to be. As far as the response from the workers, it's been mostly positive. From a perspective, Flippy is quite simple. The food can either be put in through an auto bin, which is a bin where you dump food in and it will be classified by computer vision to tell them what it's cooking and what recipe it should be. It's sequenced in order that it was put in. And then it just comes out. And so it's one job really in the kitchen that doesn't need to be done anymore. And they like the fact that it's pretty much always there and has high reliability. And the consistency of the product is quite good as well. So they're not dealing with a lot of misorders. We did have a fair amount of learnings when we first installed at White Castle, learning maybe how the operators were using it. We did make a number of changes in the first couple of months we were there so that it mimicked more what a fry cook would do, not necessarily what a robot would do. And I think as far as White Castle goes, my favorite quote from them was, we visited them after a couple of months, was, "Please don't take my Flippy away." I guess that's a pretty good endorsement. But we do find that with every restaurant there's a learning curve. And so we do training for the staff there, and we are continually kind of updating our UI, learning how to best interface with the staff there, right? They're teaching us things as well. Like recently there was a concert at one of the White Castles, and they said, "We're really upset that Flippy wasn't able to keep up with the flow of people." And we looked at the metrics and we said, well, it's your biggest day that you ever had by far at the restaurant. But in so doing that, we also are developing features so that we can act just like they would when they're in a rush, when they're getting slammed. Not things that are maybe obvious at first, but I think it's a bit of that tweaking and tuning to get it right for the customer. Yeah. Go ahead.
I'm just curious to know a little bit. I know you obviously mentioned the crowdfunding, but I've seen WaveMaker, which you're part of, does a lot of crowdfunding, and I'm curious to know why that strategy. Is that maybe because it's harder to get traditional funding? And also, I'm curious to know a little bit more about how WaveMaker operates as a whole, and do these sort of learnings translate across the different projects and stuff?
Yeah, good question. So a little bit about our crowdfunding and about WaveMaker. WaveMaker was an early investor in Miso, and they are kind of a food tech incubator almost, right? They have a number of companies that they have invested in and some that they host and sponsor. And as far as crowdfunding goes, part of that for us is it's been a successful way of raising capital. And I really like the concept there of, basically being able to democratize some of the early investments in emerging technologies. As it's been a successful fundraising for us as a startup, we're glad to have it. We're also interested in institutional investors, but so far we've gotten what we needed from the crowd. And I think it's a great way to give everybody a chance to participate. Yeah. Thanks.
Can you speak to, you mentioned cameras. Can you speak to the human and machine sharing the same space for safety?
Absolutely. So we work with a number of different safety regulations. We start with food safety with NSF, design the entire rig so that it is food safe, including the arms. That's several of our patents are around that, even putting the sleeve on the arm to keep it from collecting, any of the grease and oils that are in the cooking process. We also are in the process on CE and UL, and we map back basically to the 10218 standards for industrial robots. There's not necessarily a commercial robotic standard, but that's the one that we map closest to. We have a number of safety barriers around the robot. So primarily the operation of the robot is shielded from the humans. There's an input-output section for the food. We call it an auto bin, which is basically closing off most of the robot motion from the humans to make it safe. But it's a top priority for us, and we continue to iterate on what's the best way to interface with the users and make sure it's always done in a safe manner. Any other questions? All right. Well, thank you for your time today, and thanks for being here.